Okay, fabulous. Thanks for joining us this morning with our first opening session of Viz 2022. This is the Vast Challenge Workshop, so if that's what you're here for, you're in the right place. I'm Jordan Krauser from Smith College. I'm one of the chairs. I'm here with my colleague Steve Gomez from MIT Lincoln Laboratory. If you can see the crowd, Steve can wave. A quick introduction to our committee this year. The Vast Challenge 2022 committee was myself and Steve, along with Chris Cook and Jeremy Hack from Pacific Northwest National Laboratory. They couldn't be here in person, but they send their regards. And Alvita Otley from Washington University in St. Louis, who is currently chairing a simultaneous session. A few quick acknowledgements. Many thanks to PNNL and MIT Lincoln Laboratory for their not just this year, but many-year contribution to the VAST Challenge, to my students at Smith College who did a ton of legwork on this year's challenge, as well as the students at WashU who are running the Visual Analytics Benchmark Repository, which many of us make heavy use of. Also, thanks to our volunteer reviewers, and a shout out to our amazing tech crew and student volunteers in the back of house who are running this show. Okay. So a quick rundown of our agenda for today. We're going to start with an opening to the VAST Challenge, and then we'll introduce our Challenge 1 award winners and honorable mentions. They'll give their presentations, and then we'll have our introduction to Challenge 2 and our first presentation of the Challenge 2 award winners. Then we'll have a 30-minute break where we'll go get some snackies here if we're in person, in our own kitchens if we are zooming in from around the world. And then for our second session of the morning, we'll come back, we'll resume our discussion of Challenge 2, we'll go into Challenge 3, and we'll give a quick teaser for those who stay at the end for VAST Challenge 2023. A quick note to please visit the VAST Challenge posters, which are integrated into both the virtual and physical poster presentation session. I think we have 2 posters this year. Hello to our audience members. Feel free to come forward if you want. We're a small crowd, but you can also hang out back there if you like. All right, and even with a slightly late start, nailed it on my landing. So let's talk about the challenge of VAST 2022. Quick disclaimer, this scenario and all the people, places, groups, technologies contained therein are fictitious. Any resemblance to real people, places, groups, or technologies is purely coincidental. In Engagement, Ohio, the future is now. For years, this sleepy bedroom community has been a secret gem in the heart of the state. But the word is now out, and people are running, not walking, to buy up their claim on this bit of lakeside paradise. So anticipating this period of rapid change, the City of Engagement is conducting a participatory urban planning exercise because they want to understand the current state of the city and identify some opportunities. I'm not close enough to the mic. Sorry about that. So anticipating a period of rapid change, cities conducting this participatory urban planning exercise to try to understand the current state of the city and identify opportunities for future growth. In order to do this, they've engaged about 1,000 representative residents in this modest-sized city who have agreed to provide data using this urban planning app that the city has provided. That's going to record the places they visit, their spending, their purchases, among other things. From these volunteers, the city is hoping to use this data to assist with some major community revitalization efforts in anticipation of this wave of new people moving into the city, including how to allocate a large city renewal grant that they've recently received from the state. Today, we're going to hear from various teams of visual analytics experts who've joined the city in their planning effort to make sense of the data provided by these residents. So for those who are joining us who are not familiar with the data, I'd like to give us a quick rundown of what our visual analytics experts were presented with as part of this challenge. So the first bundle of data was a set of attributes that are sort of static over the period of observation. Things like information about apartments, buildings, and schools around the city. We also have information about the various employers and jobs that participants hold during the period of study. We've got information about the locations and prices of pubs and restaurants, their open hours, and we also have individual information about each of our participants, some demographic information, information about where they live, where they work, etc. So let's take a quick peek at what one of these data sets might look like. These files are providing some baseline context for the who's who and the what's what in the data set. So here we're looking at our information about apartments. So each apartment has an ID, it has a cost, a monthly rental cost. a number of rooms, max occupancy, and we also have information about where in our fictitious city, where in terms of geographic location defined as a point on the map, and as well as a building ID because individual buildings often have multiple apartments in them. So these files were relatively small, usually on the order of tens of kilobytes in most cases. So they fit comfortably in memory and they don't change over the course of study. Back to our different bundles of data, we also had information packaged into what we called journals. These are a little bit more of a temporal picture of what's happening over the course of the study period. So we have information on check-ins. That's where people went in a sort of 10,000-foot view. Did they go to a particular restaurant? Did they check in at work or at home? We've got information about financial transactions. So that is financial transactions between, say, employer and employee, but also financial transactions where somebody goes to a pub and pays their tab, or somebody's paying tuition for their kid in school. We've got information about travel around the city, so where people go and why and when they return, whether they spend money there. And we also have some information about the social network that's emerging over the course of the period of study. I'm getting a little bit of audio feedback, which sounds a little weird, so I'm gonna try backing up. Cool. So that social network information is kind of interesting in that it's dynamic over the period of study. So people are forming new friendships, people are parting ways, people are moving in together, etc. That's all contained within our social network data. So if we look at the travel logs, here's where things really start getting good. So journals like this travel log that I've got up on the screen, that's giving us information about who's involved, when an encounter happened, where they went. These files ranged in size from tens to hundreds of megabytes, small enough to fit in memory, but Excel gets really mad at you if you try to open them. So they're going to get truncated, so there's a little bit of a challenge there. And so we're getting, again, things like who, when, where, what people were talking about or engaging over, whether or not they spend money, and how long a period of time they spent in different locations. And finally, not for the faint of heart, but participants also had access to a base map of the city and raw activity logs of everything that's being captured by these apps over the course of the study period. So our activity logs include precise location information, as well as updates on the financial health, the hunger status, the sleep status information for every participant, given at 5-minute intervals throughout the entire study period. So in order to be able to send these off to our participants, we broke this into 72 different log files. And if we sum all of those together, that's about 18 gigs of data that span an observation period of about 3 months. So if you're curious, as I said before, all of this data is fictitious. We didn't actually engage 1,000 people to run around Ohio for 3 months. We want to thank our friends at George Mason who gave us access to the results of a DARPA-sponsored project wherein they generated a tool for doing location-based social network generation. So this is an agent-based model where you can set up a geographic region. That can be a fictional map, it can be a real map. You designate the number of participants that you want and set some initial parameters, and then you can let that run to generate location-based information that simulates real human behavior. So I found this to be a fascinating tool. It's available on GitHub for anyone who wants to play with it. So I'll lead us into our initial discussion of Challenge 1. So in Challenge 1, we were asking participants to explore the demographics and relationships of the city of Engagement, Ohio, and their end game was to prepare a 1-page fact sheet about the city's demographics, its neighborhoods, and its business base. The questions that we asked participants to address in this challenge started with asking about who is here, right? Who are we collecting information from? So assuming that our 1,000 volunteers are representative of our city's population, tell us what you can about the demographics of this town. We asked our participants to consider the social activities that people were engaging in this community. Do you see patterns in the social networks that are emerging in towns? For example, can you detect things like pub trivia teams or people who are on a softball team? Now, our information, our data sets didn't contain any information about what people were doing, right? There's no label that says, we're a trivia team. But by observing people's movement patterns, can you make an educated guess about how people are engaging with each other over the period of study? We also asked participants in this challenge to identify the predominant business base of the town and to describe patterns that they observe there. So looking, for example, at some of our employer information, or looking at the restaurant scene, or looking at the pub scene. What's happening in this town? How is that geographically and temporally distributed? Because nightlife in the town, and as well as the employer base, is going to dictate some of those patterns of both economic, physical, and social movement. From the answers to the previous questions, we then asked our participants to assemble that one-page summary that provides key information, and in particular, we asked them to focus on a target demographic of the residents of the town. This is a little different than targeting, say, the Urban Planning Committee, or targeting potential businesses that we might want to lure into the city of engagement. Here, we're asking them to focus on people who are living here now and how their city is currently using its space and its resources, and to give them a window into how that might evolve in the future. So it's my pleasure now to turn things over to our first award winners of Challenge 1. So Fudan University, our team from Fudan, received an award for their outstanding Challenge 1 submission. This was paper ID 1032. I've got a little screenshot here, but I think if we can go to our pre-recorded presentation, we'll see a little bit more about what they did.
Hello everyone. In this talk, we are going to present an interactive visualization system designed for solving VAST Challenge Mini Challenge 1. This work is completed by Yu Xiaoli, Xue Wang, Yue Wang, Ting Liu, Wei Ting Wang, Ziyue Lin, Siming Chen, and the others are from Fudan University. We will first give a general introduction on the system. Then, we will talk about our data processing and system design in detail. And last, we will show how users may get insights using our system through a case. Mini Challenge 1 requires participants to identify the demographics of the city, and also the social network and the business base, and the patterns of both of them. The provided data are attributes of the participants and activity logs, and also the journals such as the financial journals and travel journals, and also the social network data and data for the buildings. First, we discussed the definition of a business base. After consulting the committee, we determined its basic meaning. A business base is actually the set of businesses operating within the city. To be more specific, it can be split into two areas. The first one is where the participants work, such as the companies and so on. And the other one is the place where the participants spend their money, such as restaurants, shopping malls, and so on. And then, in this part, we are going to introduce how we implement data processing. Here is the basic information of the data we have. As for the attributes of the participants, we could get the basic attributes of them, such as age, educational level, and so on, but we could not get the location of the participants' residence. As for the social network data, we can get when the social event happened and who was involved. But unfortunately, we cannot figure out where did these events happen. And we could get the immediate status of the participants, such as if they are at home or not, and also their consumption and the purpose of their consumption from the journal. Here are the algorithms that we used during the data processing. First, we did HDB scan clustering for the locations of employers, pubs, restaurants in order to find the business base. And then we used K-means to cluster daily social network data based on different K-values in order to analyze different social patterns. The location of the participants' residence are essential to get the characteristics of the population distribution of the city. So we used the activity logs to figure out the location of the participants' residence through the position of the participants when the status of the participant is at home from the activity log. In addition, we included angle coefficient as an additional attribute of the participants, because the angle coefficient is an important indicator of the standard of living. We also combined financial journal with the activity log through the participant ID, timestamp, and so on. And then we selected the consumption required step for food or recreation. And then we calculated the average consumption value and number of consumption of each base, based on the records selected above. Also, we used the activity log and saved the records of at-work status and displayed them by day. By means of job ID of the participants, we get the hourly rate in the jobs dataset and calculated the hourly average wage and number of workers a day in each base. At the same time, we processed social network dataset by days. We counted the number of social interactions per participant per day to derive the ID of the most socially active participant per day. When we explored the single attribute of participants, we found out that each value of the attribute take almost the same proportion. This means that exploring a single attribute makes it difficult to get a demographic profile. So we considered combining different attributes, which might lead to unexpected results. And the next part is system design. Our visualization system is mainly built with D3GS and Vue.js. Our system includes a map in the left, a calendar selector, a search clustering view of social relationships and a base view in the right, and also a reader view in the top right. The 5 components of the visualization system coordinate with each other to support the exploration and discovery of demographic characteristics, social relationship patterns, and business-based pattern characteristics of the city. The map view is used for demonstrating the attributes of the participants. The map view supports the joint selection filtering and cross-sectional distribution display of multi-class features for demographics. The participants are scattered as dots on the map. Their position on the map is determined using the location of their residence. The type of street is mapped to the corner. Blue for commercial, green for residential, and red for school. Initially, all participants are uniformly represented as small blue dots of the same size. By clicking on the ATTR selection button, specific attributes can be filtered and different attributes can be combined. After selecting all the attributes you want to observe, you can click the Analysis button on the top left to observe the proportion of values taken by all participants with respect to the selected attributes. Since participants have many attributes, we designed an additional auxiliary tooltip that, when the mouse hovers over a small dot, a rated plot of the participants' base attributes appear for auxiliary analysis. Also, the map view has 3 modes. The figure there shows the initial modes, the demographic mode to describe the demographic features. The red dots on the map in the top right means the participants who are eligible for screening after selecting a value of a specified attribute. Visualization of a specific attribute can be performed by clicking on the Scale Selection button, which maps the value of the selected attribute from small to large to the corner and observes the distribution of different values of the attribute over geographic locations. You can see it in the bottom right. And in the top right is the Activity Location mode of the map view. This mode displays the location of the participants on the map on a non-commuting day according to the selected date. And in this mode, clicking on the semicircle in the base view makes the map view show the distribution of the participants' location on the corresponding day. And in the bottom, you can see the business base mode of the map view. This mode displays the geographic coordinates of all the restaurants, pubs, employers in the city, which are clustered by HDB scan and adjusted to the city map structure to get to the four main business bases as shown in the figure below. And then we are going to introduce the calendar, reader view, and the base view. They are more interconnected with each other. You can select the date you want to explore through the calendar. And in the radar view, there are two modes. The first mode is the business mode, which displays the number of people working in the site on a daily basis, and also the average hourly wage of each base. As for the commercial base, which displays the number of people who spend money in the base per day, other than transportation, and also the average spending level per unit of each base. And the reader view calculates the average distribution of the two headcount characteristics with respect to the day of the week for the 30 days before and after the selected date, which helps us to explore the distribution characteristics of the headcount identity with respect to the day of the week, as shown in Figure C. Now let's talk about the base view. The base view shows the daily characteristics of each base for the 30 days before and after the date selected in the calendar. The red semicircle indicates the work situation. The radius size indicates the total number of people working in the base on that day. And the corner shade indicates the average hourly wage of all people working in the base on that day. The blue semicircle represents the consumption situation, and the radius size represents the total number of trips made in the base on that day, except for transportation. And the corner shade represents the average consumption level per order, as shown in Figure E. The relationship view also has two modes. Mode 1 to display the most socially active participants on the selected day, and Mode 2 to provide details of the selected participants. You can see the Mode 1 in the top and Mode 2 in the bottom. The figure in the left is the Mode 1 of relationship view, which shows the 6 most socially active people per day, based on the date selected by the calendar. Each person's business card shows basic information about the individual, and details are displayed when hovering over the magnifying glass button. We can also enter in the input box in the top left corner for the exploration of the social connections of a specified participant that we want to find for that day, but the ID must be legitimate. We can click on the Explore button to switch to the Mode 2. Now let's talk about the Mode 2 of the relationship view, which is designed for the exploration of the personal social network. On the left is a first map, where each node is an ID and each edge represents a social relationship between two people. Each edge can be categorized by selecting the k-value for k-means clustering, making it easy to view social patterns, as well as selecting the specific category of social patterns you want to view from the drop-down box. A node or edge can be selected from the first guide to further select the desired information. On the right is a view of the relationship between the two people on the selected edge, in which you can see the time, distance, duration, and some basic information about the social relationship that occurred between the two people after matching. At last, we are going to play a small video about an case. First, we can see the initial status of the map view, where each participant is shown as the blue dot on the same size. And by hovering over the dot, we can see information about him. By clicking on the ATTR selection button, we can filter the values of the attributes, and participants who meet the conditions will be displayed as red dots on the map. In this case, we selected participants whose angles coefficient is higher than average. We can see the result on the map. By clicking on the scale selection button, we can select the specified attributes to map the corner of participants. By clicking on the analysis button, we can see the statistical analysis of the selected attribute. We can see that the people in this case who has higher angles coefficient tend to not have cats. We can see that this is the demographics mode of the map view. And this is the activity location mode. And this is the business mode. We can select the date through the calendar. And in this case, we selected the 5th of September. After selecting the date, we can see the basic working and commercial situation of each base in the radar view. In the base view, we can also see the basic working and commercial situation in each base within 30 days before and after the selected date. In the relationship view, in mode 1, we can see the 6 most active people on the selected date, and then we select the participant to explore. We can observe his basic information through the magnifying glass button, and then we click the Explore button to switch to Mode 2. We select Cluster 5 to explore more, and we choose a random node and an edge, and we can see the details on the right. To conclude, as for the demographic characteristics of the city, we mainly use the map view to explore. We can select a specific attribute to figure out the distribution of the values of the attribute on the map. And also we can see the distribution of people's location on the selected day. And as for the social network pattern, we mainly use the calendar, radio view, and the relationship view to explore the patterns. After selecting a date, we can see the consumption and work situation of each base in the radar view, and also the social activity situation in the relationship view too. That's all we want to share with you about our system. Thank you very much for listening, and here is the homepage of our laboratory. If you have any questions, you are very welcome to contact us.
Fantastic. Thank you so much. Could we switch to Zoom? Great. Yushao, are you on with us? Yushao, are you on with us now? Please bear with us while we have our tech crew help us get this sorted out.
Okay.
Hi there.
Hi.
Fantastic. Could we full screen the Zoom, please?
Okay.
All right. So, Yushao, I've got a couple of questions for you here. If you wouldn't mind unmuting your video if you have a chance. So the first question that I've got is coming from Steve. Steve says, impressive analysis. Just curious whether there were any insights you gained from the hierarchical part of your clustering using HDB scan on the business bases. How do you know what the right number or breakdown of clusters is for these bases?
Well, thank you for your question. And as for the base view, actually it is designed to to find the work status and consumption level of each basement. And in the base view, it can be seen that this cycle which is used to present the week, the work status is very pronounced. For example, the racing circle, which is like to be present the work status, is particularly evident in base 0. And the radius of the semicircle is like
significantly drops at the end of the week, which is the weekend. The radius, which I have mentioned in the video, it is means the number of people working in this basement, which means that there is less workers in the weekends in base 0. And this situation is also accompanied by a light corner. And the corner of the same circle also represents the average wage of each worker. Also, this means that the average wage is not that high in the weekends when compared to the weekdays. And this feature is also present throughout the whole period, as well as in the other 3 basements. But actually, in contrast, the blue semicircle, which is used for represent the consumption level, is not that significant in the base view. So this is the basic finding that we figure out from the base view. And as for the number of clustering, actually, HDBS scan do not need us to choose like a cluster number. The algorithm will choose the cluster number itself. So maybe we actually do not know if it is right that the result of the the number of the basements is right or not, but the algorithm just chose to get this result itself. And that's it. And hope it can help you to understand this part. Thank you.
Thank you so much. So I think we've maybe got time. I'm going to squish time a little bit for one more question. So this is coming from Yang Shang. Can you elaborate on how to find the different social patterns in the force maps?
Okay, thank you for your question. As for the social patterns, the first thing that we need to do is just to find the clustering algorithms, and we just picked k-means. And we took all the participants' social records involved in the participant on the date that you have selected in the calendar as the training data set. And also we combined the features of the 2 participants themselves involved in each social networks or social records, the features of the social data sets. And the k-means clustering results are actually calculated in real time according to the k-values you have chosen, which means that the results will be different depending on the k-means values you have selected. And then we will figure out the social patterns through this process. And that's it. And thank you.
Thank you so much. Those who are live, please thank our speaker. And if we could hop back to the presentation. Awesome, thanks. So up next is our Challenge 1 honorable mention, which goes to TU Darmstadt and Fraunhofer for their extensible custom dashboard for their submission number 1013, Visual Analytics for Urban Data Analysis. I think we can step to their pre-recorded video.
Hello, and welcome to my talk on the work of our team for Challenge 1. This is a team of 4 students from the Technical University of Darmstadt, and me as a researcher from Fraunhofer IDD, also from Darmstadt. I will start with a very brief introduction on the data and tasks of Challenge 1, then lead over to our approach and walk you through our application in a small live demo. In this challenge, we got access to a 14-month survey of a fictitious city in Oklahoma that captured a variety of information about the city. We have descriptive information about participants, buildings, businesses, jobs, and social venues, as well as detailed logs of participants about daily activities, interactions, and financial status. All in all, a large pool of data. A significant characteristic is that all data entities are strongly linked with each other. So, for example, a participant is linked to their apartment building, their employer, to social venues, to other participants, to social networks. Every piece of information is also linked to a spatial location within a city, either through buildings or a tracked location. We were given the viewpoint of a data analyst within the city's planning team, tasked to prepare a report of the demographics, business, and social life of the city. Our job is to provide a solid data foundation to support decision makers how to direct investments for future growth of the city. Not that easy. Now, we all know visual analytics is a great approach, maybe the best, to incrementally build an understanding of a complex and interlinked data set like this. We wanted a tool to help us dig through all of this interlinked data. Something to give us an overview, but also the option to drill down into interesting subgroups of data points. Something flexible, so we can easily check hypotheses along the way, and maybe follow-up questions from the results. And we wanted everything linked to the map locations, as we expected to see special patterns in the data. Every real city has well-known, dedicated districts with characteristic communities and distinct patterns of social behavior and activities. In the end, we settled on a set of interactive dashboards, each focusing on one aspect of our report: demography, social networks, and business. So we went through the pool of data and gathered everything that we thought might be interesting for our cases. The static attribute tables were obviously related and easy to integrate. But we also processed and stored derived data from the large activity logs. For example, we created new attributes like operating weekdays of businesses or mappings between participants and their jobs and apartment buildings. During the process, we encountered several, we guess, intentional errors in the data, including a set of participants that vanished from the data logs after the first month. We will come back to those later. 2 web services finally managed the resulting datasets and process queries and statistics on them as requested by the web application and the user. So here are some example screenshots of our 4 dashboard pages. The overall structure always remains the same. We have a map of the city on the left to visualize spatial information, paired with dashboards for abstract data on the right. So I believe visual analytics is not really great shown on slides, so I thought I'd just give you a demo of the live application. So here we are. This is the first page, the demography page, which gives us an insight about the actual participants' data. So we have here distributions for age, education level, whether they have kids, interests, etc. So this is our overview that we started with. For example, we can see for the whole population, age is fairly similar across all age groups. Education level is peaking around high school and college degrees, etc. All of those give you a general idea over the whole population, but they can also be used as selectors. For example, I can select here the have kids properties to only select families with kids. And the dashboard is updating according to the subgroup, right now 301 participants. The map is also filtered accordingly. So we are drawing each building with a different color according to their category. For example, residential buildings are green, commercials are yellow, and in light blue are apartments. So right now, these are the apartments where these families are living. So we don't see any special clusters here, but everything is fairly distributed evenly. Let's remove this filter again, and let's get back to these anonymity participants that we saw earlier. We have added them as specific widget here, so we can select these patients that drop out after the first month and see what we can find out about them. We don't have location information for them, but unfortunately we see structure here. They do not seem to be highly educated. Joviality levels are relatively high, and there are no singles in this group. So these groups seem not to be randomly sampled, but they seem to have structure, and this might become a problem in the analysis. For the next part, let's just select the ones that remain and have a look at the financial status dashboard at the bottom. From the financial logs, we have deduced the available balance that each participant has in their pocket after every day. And this is the average here for the whole data set. And we can see they are all going up, which is good in general. We can also split them by, let's say, education level, and we get an, well, not so unexpected result. Very much here on top is the purple curve, which are graduates in education level. And basically what we can see is the more you earn, the more money you have in your pocket at the end of the day. What is an unfortunate proof, however, is the blue and red curve. The blue curve is all participants, including the later missing ones. The red one is the selected average right now, and they do not match. So we can see that these missing participants actually have an impact on analysis. Let's have a look at the social network next. Here we go. And we have been digging through the interactions between people, and given a time range, we're taking the whole time range now and the frequency threshold. We are creating a node link diagram with each node being a participant and each edge being a strength of a relationship between them. When people have met at least 350 times in this time range, we add a connection here, so we don't overload the whole chart with too many meaningless connections. And we can see a lot of 2 or 3 pairs, but we also have some larger connections. For example, we can select this one here. And the dashboard is updating now to this selection. Right now, 47 participants, and we can see if they might have any traits in common. What we also see on the map, and we see a new feature here, that are lines. In blue, again, are the buildings where the participants are living. So what is interesting that they are all clustered in this area here on the upper left. The blue lines are now links between participants. So this is the social graph on the map now. And we are also adding the employers of these people. And we can also see that they are centered here in this area. And the yellow links are the connections between participants and their employers, which is an interesting fact. We guess these might be some kind of workplace-related social communities. We also have a feature for the map to see them in 3D. Sometimes when you have these dense networks of links, it can be helpful to have the third dimension to entangle these large hairballs and see some connections you might have missed, or see a bit clearer through very densely populated areas. We can also, if we remove these links here, have a look at this specific district here, and we've now selected all the commercial businesses which we can further investigate on the business dashboard. Here we have an overview over the employers of the city and the jobs that they are offering. So we get statistics about number of jobs, percentage of open jobs, and total payment to get an idea how large these companies might be. In this case, we have selected the subset of all the employers that are here, and we can compare them to the whole population of employers, which is the gray bars. Or maybe we can also select another one like the companies in the city center and see how they are. They might be different, if there are any specialties, if they are really larger or something. These both sections are linked, so we can also select here, for example, the employers with a lot of open jobs, and the job section below are these jobs that these employers are offering. So these two sections are linked to each other, and we can see below some more details about employers in a sortable table. This is the current selection, and we can see if we can maybe find any correlations in these deep diving by only looking at the ones that have many open jobs, if they are somehow correlated with the size or the total payment. Or we can also sort by wage gap and see if companies with a large wage gap are usually the larger ones, seem to be a bit like this. And also how they are offering work on weekends and required education, etc. to really dig deep into these details. We can also add here the, if we go back to, let's say, city center selection, have a look where people, the employees are living, and add here, again, these links on the map to see where they're coming from. In this case, it looks like in the city center, people are coming from all over the city to work there. So our last dashboard, let me remove the links, is the gastronomy dashboard, which shows us how people are visiting gastronomy, so restaurants and pubs. We have aggregated the total number of visits and unique visitors over time. We were wondering if there are any changes, and it seems like there is very, very stable. So we have basically the same number of visits and visitors over the whole time. We can also see that visits per participant are extremely stable and frequent. So pubs and restaurants seem to be a very a very important aspect of social life in the city. We can ignore the first months. We can see them because they have these anonymity participants here. And for each restaurant and pubs, we can again go to the sortable tables and see if there are any correlations between, for example, when they have opened, when they are at their peak business times, that you can see here, and how large they are. And we also have these work lines that show you how they have developed over time. Most of them are relatively stable. You can also visualize where the guests are coming from. In this case, we noticed that restaurants, for example, serve guests from all over the city. For pubs, we have two very, very large pubs that seem to be very popular over the whole city. Most of them, however, are more or less focused on their specific district. And what's also interesting that if you're looking at when they have their peak business times, pubs seem to be basically only doing their whole business on weekends, whereas restaurants are much more diverse. So this has been a very short look into our application that we developed for this challenge. I hope I can give you a first glance into that. And with that, I would like to say thank you very much for inviting us today. Huge thanks to the organization team behind this year's VAST Challenge. It was absolutely great working on this data set. We have certainly learned a lot from it, and we will most likely use it again as a reference. Thank you very much for your attention.
All right, fantastic. If we could hop over to Zoom, please. Excellent. And Jan, are you with us?
Yeah, hello.
Fantastic. Okay. So I've got a question for you from Anonymous. Adding the 3D view to the map was very neat. What do you use to encode the height of those buildings, assuming that was not in the data? Is it helpful to the demographics analysis?
The height of the buildings, there were some things about, let me think, for residents, there were information how many, apartments are there, and for business buildings, there were information how many businesses are in this building. So by kind of counting how many businesses or apartments are in one building, we set the height. So kind of thinking like there might be some patterns regarding that there are like not skyscrapers but large apartment buildings or rather small buildings, which might be interesting to also to correlate with the people living there. And excuse me, what was the second question?
The other part of the question was it useful to your demographics analysis?
Oh yeah, this was what we thought. I don't think it was pretty mixed. So what we expected, what we thought there might be, that there might be some areas in the city where there are like many small buildings, like where maybe people are living with relatively high income, or there are some areas that where buildings are very large, which usually are large apartment buildings for people who may not have this high income. But I think there were no direct correlations, if I remember correctly. But this was the idea that we want to see from the 3D view also, to correlate them with the kind of people living there, so demographics. Yeah.
Great, thank you. And we have a question from Chris Cook. What are the things in your design that you felt worked best, or in the? Oh, hold on. And what would you have added? And actually, I'm gonna tweak that a little bit. You said that this data set was of particular interest to you. What about the design of the data set worked really well for you and your team that you'd like to see replicated in future VAST challenges?
I think so. The first thing is the volume, obviously. This was a team from students, bachelor students, and working with a large data set was certainly something that was new and different from lectures. It is great. And the second one is that everything is very, very interlinked. I think it was very special. So the data sets I usually work with are not of that kind, and working with basically so many interlinked data was a challenge and really interesting. So basically people are correlated to businesses, to pubs, to other people, to locations. This was, I think, special, and I'm very interested to work on, and we will continue working on this.
Fantastic. Let's thank our speaker.
Thank you.
And if we could hop back to the primary presentation, please. I'm going to turn it over to Steve for our introduction to Challenge 2.
All right, thank you, everybody. Let's talk about Challenge 2, which is all about pattern of life analysis, right? So this is sort of taking a mile-high view of the dynamics that are going on in this city, in particular what's going on in the lives of the individuals who live and work there and the businesses. So with Challenge 2, we had 4 big questions that we wanted folks to try to tackle regarding pattern of life analysis. The first is that if we can assume, again, that all of the volunteers that we're collecting data from are representative of the broader city population, by that way, that's a really important assumption to make when you do this kind of analysis. Can we characterize what's going on in these areas of the city? What makes them distinct from one another with respect to patterns of life? The second question is, where are the busiest areas in the city? And it was up to the teams to really figure out how they were going to define that, right? We have this map data. We have these travel journals where we can see how people are moving around. Could we use that to find traffic bottlenecks and maybe make recommendations about where the urban planning should, address some of these issues? The third question that we wanted teams to focus on here is, given that we have participants who are volunteering us to look at their daily routines, can teams look for pairs of individuals in the data who have really different patterns of life, right? And then analyze and kind of compare and contrast those patterns. So the kind of 2-part to that is, can we select a good pair that represents really distinct patterns? It's important to know that you've kind of picked 2 good examples to contrast. And then how do we go about telling a story about what might be going on in the lives of these people? And that's a big part of, this year's Challenge 2 is really thinking about, what can we hypothesize about what's happening in the lives of these people? It's really important for this kind of analysis. And then finally, over the span of this data set, how do we see patterns in the city change, right? So with respect to all of these issues, how busy are certain areas? What's going on in the lives of individuals? Can we characterize any kind of broader changes that way? So I'm pleased to announce for the remainder of this session, we are going to have a presentation for our Challenge 2 award winner. And this was for submission 1017 by Joe Wood at the GI Center at the City University of London for his work on patterns of life analysis with observable notebooks. And we really thought that this was a comprehensive Challenge 2 submission. There's a lot of creative use of technology here that gets at really interesting insights. And we'll hear a little bit more about Joe's sort of philosophy for how to do this kind of data analysis. So with that, why don't we switch to Joe's pre-recorded presentation, and then afterwards we'll have the Q&A. And I'll remind everybody, please ask questions using Slido so that we can have some good discussion with Joe after. All right, thank you.
I'd like to say something about how I approached this year's VAST Challenge, but before I give you any of the details of exactly what I did, I'd like to say something about the approach and perhaps generalize some of my experience to think about how we do visual analytics for the kinds of tasks that this year's challenge addressed. And I want to start by observing that I think this year's challenge was slightly different to previous ones, and different in an interesting way. And in a way that I think makes the challenge more realistic and certainly more aligned with the kinds of data-driven visual analytics that we commonly practice, certainly in the group that I'm part of. And to observe what those differences are, we can see that, for example, the data set that we had this year was pretty large, 18 gigabytes of data uncompressed. And that has implications for the way in which we integrate the data with the visual, because typically 18 gigabytes of data is not going to be suited to full in-memory processing of the entire data set. So there are some filtering operations we have to apply to bring the data down to size to make it more amenable to visualization. But what I particularly liked about the challenge this year was that it was asking questions not about finding a needle in a haystack, finding a particular item in a large data set, you know, the criminal behavior of an individual or anomalous behavior of people, but rather it was just asking more generally about trends, patterns, and interpretations of those patterns that we might have observed. And that, certainly in my experience, is much more closely aligned with the kinds of approaches that visual analytics, certainly that we use for visual analytics. I'd also like to say something about the general approach that I've been taking with these challenges. And I guess I want to advocate this idea of literate visual analytics. And that comes from Donald Knuth's idea of literate programming, where he said, rather than just create code to perform a particular function, we interleave that code with textual narrative that is explicit about our reasoning, in his case, for the particular design of algorithms that we might code up. But in a VA context, literate visual analytics, I would argue, is about integrating the process of constructing the visual, of performing the data analysis, and critically, in explicitly reasoning about the design, the visual designs, the findings that arise from the analysis, as part of the same process of actually doing the analysis and constructing the software that allows that analysis to take place. It's a far more integrated approach. And I've done this in the past. A few years ago, used some software that we wrote for literate visualization, where we integrated this idea of constructing the code to do visualization with the notes about the analysis process, the conclusions that we might have drawn from it. And it allowed a much more structured approach to the VA activity. And it forced me, at least, to confront the assumptions that you would make when you're going through that process. And I would argue that that is quite a valuable way of conducting visual analytics. This year, I took the same theoretical perspective on performing visual analytics, but used a different platform. And in this case, we used the Observable platform. If you haven't come across Observable, this is a web-based notebook environment based around JavaScript. But crucially, it allows you to do everything on a web browser and allows you to share results on a web browser very straightforwardly. So we've got a platform for performing visual analytics and an approach that says, don't just create the visual, but also reason about it and be explicit about that reasoning in the same environment that you would use for the code itself. You can see the examples of those pages I've got on the screen by going to the URL there at the bottom. So how did I approach the actual process of addressing this challenge? Well, for me, the key starting point is to try and orientate myself around the data. What have we got to deal with here? What might the data have the potential to reveal? And although there are sort of meta descriptions with the challenge, I find visualizing the data in a fairly straightforward way to start with a really important part of just orientating my way around the data set. Now that involves a few technical file transformations. So for example, there are spatial data in these challenges. I converted those to GeoJSON format, which was fairly straightforward, with the data were provided in something quite similar to GeoJSON. And that allows for easy mapping of the data. CSV data were put into Arquero tables, essentially a relational database system that allowed me to filter, perform joins, etc., the kind of typical relational operations that will need for extracting some of the valuable data and bringing it down to size. So as an example of the kind of orientation tasks that I confronted with this particular challenge, and the way that visual analytics, literate visual analytics can help with that, I just want to identify one example here. And that was the scale of the data. Now, the data are geographically located. They use a coordinate system that we were told about. And initially, we weren't told how, on the ground, what scale those coordinates represented. Was 1 unit 1 meter on the ground? Was 1 unit 10 meters on the ground? So by visualizing results and interactively being able to switch scales, we could explore, well, if this was 1 unit is 10 meters, how large would this city be? How large would the streets be? So, for example, if it was 1 to 10 meters here, that would mean that these buildings that we can see here would be 4 kilometers long. And it would mean that the width of the street would be unrealistically wide. And in this case, I was looking at the speed of movement around the city, which of course will be dependent on how far we're assuming people are moving. And one of the outcomes of this, and we could look at various individuals and look at their speed profiles or their movement profiles across the city, was that the speed seemed rather unusually slow. And in fact, it was very rare that speeds ever got above 6 kilometers an hour. And typically they were more like 5 kilometers an hour. Now that might suggest that the units were actually larger than that, maybe they're 10-meter units. But as we've already seen, that would give a rather unrealistic scale to the buildings and the street layout. So this was one of the kind of key early findings in the orientation process, that the speeds of the movement throughout the city were unusual. They were essentially walking speed or slightly faster than walking speeds. And this led to some hypothesizing about why this might be the case. At one stage, I thought maybe this was a religious community where people moved around on foot or with horses rather than motor vehicles. But some of the other data, of course, the street layout and the frequency of pubs across the city and the nature of the workplace suggests that probably wasn't the case. But nevertheless, we had a document here that allowed us to explore that assumption. The other orientation process that I'd like to, well, I applied here, was to just get a sense of where people were actually moving around the city and when they were moving. Now, the task itself asked us to identify some of these trends, but before you sort of summarize the trends, I just found it useful to glimpse what was going on. And I like this model of the sort of city as a petri dish, where we can, through an imaginary microscope, look at the city, look at the behavior, just observe it, just to get a sense of what's going on. And that formed part of the rationale for some of the early coding here, where we could just animate movement of the individuals around the city. And I was selecting here, because we've got a very large data set, just a few weeks of from the longer period of time here, just to get a sense of what was going on. Now, this wasn't directly to answer any of the questions of the task, but it helped in orientating myself and thinking about, well, what are the likely trends that I'm going to need to be able to explore? And that idea of just observing rather than synthesizing at the early stage, I found quite useful. This ultimately allowed us to think about how we might subdivide the city into more useful units, sub-areas, which indeed was one of the questions in the particular task here. The details of that are already documented in the answer, but that early stage of animating and seeing the movement was quite important in arriving at those regions, the letters A to G here on the screen. So I mentioned that one of the characteristics of this year's challenge was that it was a large data set, and inevitably that meant that I had to think about how we were going to bring the data volumes down to size. And there were lots of ways, of course, typical ways you do this in a typical piece of data science. You filter data, you select only some parts of it. And in this case, extracting only certain columns from these large CSV files, such as the locations of individuals, which is what I used for the animation that you saw before. Sampling, either random sampling or sampling from a small number of participants or a small time window was important in being able to get that orientation sense I've talked about. And of course, aggregating. Spatial aggregation into grid cells, that was one way of cutting the data size right down. You can see on the right-hand side there, a map of the city where we're just looking at grid cells and looking at the density of movement and the average speed within each grid cell over selected periods of time. What we're doing with visual analytics is not just describing data. There can be a temptation to simply show all the data, a bit like what I was doing with the orientation stage here, and assume that that's enough, that all we're doing is re-describing the data set that's been presented to us. But of course, the task involved us doing more than that. It involved us synthesizing the data, analyzing, extracting trends, generating knowledge. And that, of course, is the central part of visual analytics. It's that transformation from data into knowledge. And I find the literate visual analytic approach useful in building up that narrative and disciplining oneself to think you're not just here to describe what's going on, you're here to understand what's going on. So there were lots of ways in which this happened. One of them was to think about how might we take typical observations and be reassured that they represent a wider pattern of behavior. And indeed, one of the questions that asked us to select 2 participants and describe their behavior did exactly that. And that was a process that we went through, again, using the observable literate visual approach here, where rather than just randomly select individuals or perform some database query that said find the individual with the longest travel distance or whatever, what I wanted to do was to get a sense of the data set as a whole in order to be confident that the individuals that we chose were typical of a wider pattern of behavior. And one way of doing that was, I applied here, was to create parallel coordinates plots and then interactively browse participants, individuals, to see how their individual behavior related to the group as a whole. And one way of doing that was to order these, each individual in the data set by a variety of different characteristics. So we might order them by the travel time or the amount of socializing they do. And then we can browse the individuals in the order of the thing I've just selected. So here we're looking at going from the most social to the least social in order to get a sense of how much an individual might relate to the group. And that was all linked in these tables to when we select one person. This is person 614 here, for example. We can see their behavior. This in here is a calendar view, and we can see their movement across the city here. And these are all linked together. So as I browse different people, any one map view changes along with the other views, the calendar view and the parallel coordinates view. And then finally, I wanted just to give an example of how we again use the literate visual analytic approach to start generating new knowledge about these observations. And one of those encapsulations of that knowledge was in fact this idea of, well, what are the subunits of the city that might be meaningful? We weren't presented with boundaries, we were asked to subdivide the city into these smaller units. And one way of doing that was to use the movement of people as a proxy for the identity of the regions that people move between. And one of the particular characteristics of the movement was that there were some very long journeys that moved between an origin and a destination that weren't very far apart. If we look at the typical commuting patterns here of all the people in the data set, we see movement along these common roads, the busy ones that everyone moves along. But we also notice, for example, that there are some journeys between zones E and F, for example, here, which are quite close together as the crow flies, but the route taken is much longer because they're constrained by the road network. And those kinds of observations, well, I mean, we may be able to glance at the map, but we can actually explore interactively in these notebooks, for example, by quantifying the journey efficiency. In other words, the ratio of the length of a journey on the ground along the road network compared with the straight line distance between origin and destination. And we can filter those journeys so that we only look at the most or least efficient ones. Here we're looking at some very inefficient journeys that go a very short distance as the crow flies, but take a longer route to do so. And that helped in defining, well, what are these sub-regions here, and what kind of future planning might be appropriate in making those journeys more efficient in order to cut down on congestion, for example, if there is an opportunity for people to walk or move the much shorter distance. So what we're doing here really is moving beyond the kind of, here's a description of the data, and thinking about the understanding of what the data mean in the context of urban dynamics. And I think that's quite important. And I would argue that the literate visual analytic approach was really helpful there, because I could reason in the ways I'm doing at the moment, but actually on as text, as I was exploring the data and as I was choosing what kind of visual approaches to take in revealing patterns in those data. So let me conclude by making a few observations about the process and reflections on my experience of this year's challenge. I really appreciate the fact that the challenge this year felt more like a real world analytic task, at least more real world in the kind of task that I'm used to performing. I tend not to do the kind of needle in the haystack, find the criminal behavior type tasks on a day-to-day basis. I'm much more likely to be doing these kind of, well, what are the structures and the patterns here? What can we conclude? What implications does that have for future planning, etc. So I hope we see more of those. I think they're interesting challenges and present interesting visual opportunities to address them. As I have been saying, I would argue that the literate visual analytic process has been really valuable in ensuring that this is a reasoned approach to understanding here, that assumptions made about the data set are in the forefront of my mind as I both perform the analysis and develop the software to allow that analysis to take place. That has been very helpful. And I also just want to acknowledge that the generation of the challenge itself must have been itself very challenging. I mean, this is a large data set, some really interesting patterns to find out here, discover. And clearly the process of creating the simulations that allow this to happen involved a lot of work. And I appreciate that, but I guess I was in part left a little bit dissatisfied with some of the conclusions that I ended up drawing, in that it felt like I couldn't provide explanations about why, for example, the maximum movement speed across the city was essentially walking speed. Now, I could imagine there might be good reason for that. You could imagine, as I said, a religious community, or one where there has been some radical policy decision to prevent any motorized traffic within the city. Now, that's a really interesting idea to explore, but I would like to have seen that maybe triangulated with some of the other observations or some of the other characteristics of the data that might support such a hypothesis. It would be great to be able to uncover the story, as it were, that explained the way that these different characteristics work. If you want to find out more about my particular approach to the problem, the URL there at Observable has the details of the approach I took. Thank you very much.
All right, can we switch to the Zoom, please? Joe? Let's see, Joe, can you hear me?
I can indeed.
Okay, so I think we might only have time for one question because we're a little bit behind, but man, I really loved this presentation and the solution, and I really appreciate that. Especially the point that you made about, right, visual analytics are useful not just to retrieve some quantitative outlier, but to reason about it with the semantics of the data in mind. And so maybe I just will ask, when you did find things like that, there were some of these very inefficient journeys, like, did you try to go back and, using that platform that you have, see whether that made sense within, some of the other data modalities you might have been looking at? Is there something about this platform that would help you go back, when you did run into bumps like that? I know you said with the walking speed or moving speed, it was kind of hard to confirm some of that, but how does this platform in general help with that kind of analysis?
Yeah, I think that's a really good question, and I think it helps because I was forced to be much more explicit about those assumptions and those things that still remained uncertain. So this whole idea of why nobody moved faster than 6 kilometers an hour was quite in the forefront of my mind. So when I was thinking about, could you add extra roads or routes? I was thinking, well, actually, if these are people who are walking about, they don't need to be roads. They can be footpaths. And so it was the act of going through those earlier stages of questioning uncertainties and making assumptions and having that documented helped me, I think, when I was hypothesizing about what you might do from a sort of planning perspective. And as I was saying in the video, the reason I like that is because that's what we do in the workplace, really. That's much more common, those kind of thoughts. And having it documented in a reasonably systematic way helps, I think, in intelligently sort of asking those kinds of questions and potentially answering them.
Yeah, and I imagine having a platform where you can document the things that you tried that didn't work out well is very useful in real world analysis, right? To verify those assumptions.
Absolutely, yeah. And what I didn't say there actually was that this platform allows you to do that collaboratively as well and explore those ideas with other people. And some of our early discussions about speed and the like were with colleagues in the GI Centre who could access the same pages, etc. So that does help, I think, having a platform that can be shared with others when you're doing that hypothesizing.
Awesome. So let's thank Joe. I think that was amazing. And actually, I think we're at the end of this session. So there is a break for about 30 minutes. I think we'll convene here at 10:45, if I have my time right. And we'll follow up with actually 2 honorable mention presentations for Mini Challenge 2. So remember this patterns of life analysis. We're going to come back to that when we get back. But thank you.